Welcome to End is the Future, a podcast that brings together great minds to address the opportunities and challenges of making businesses both sustainable and profitable. I'm Ilham Kadri, the CEO of Science Co, and I'm delighted to be your host today. If you are as passionate about sustainable business as I am, let's explore how End is the Future together. Hello, everyone. For some inspiring summer listening, we are resharing some of our favorite episodes on the power of science and chemistry. This is a special episode on chemistry and cooking with Christophe Lavelle, an expert in molecular gastronomy. I hope you enjoy it and stay tuned for our next season featuring our customers and partners starting in September. I'm truly delighted to be in this lovely kitchen studio. Yes, chemistry and kitchen, cooking. And I'm today thrilled and honored to welcome Christophe Lavelle, who is one of the foremost experts on the chemistry of cooking or molecular gastronomy and the relationship between arts and science. Christophe has a PhD and is a teacher in biophysics and epigenetics. He's a researcher at the Centre National de la Recherche Scientifique, le CNRS, co-founder of the Food 2.0 Lab, and runs a lab at the National Museum of Natural History in Paris. His research focuses on the regulation of gene expression and the biophysical properties of macromolecules, including the one you eat. He teaches in many universities in the world and establishments throughout Paris, including the famous Le Cordon Bleu. So let's get started, Christophe. Welcome. Hello.
Hello.
Really so proud and thrilled to have you here, Christophe.
My pleasure.
So tell me, Christophe, you are French, I believe, right? So how come a PhD, a teacher, a worker, you are employed by the CNRS, which is one of the fleurons of the research centers in France and beyond, can do cooking?
First, because at the CNRS, we like to study everything, which means we have people working on sociology, history, and physics, chemistry, and biology. And cooking is indeed gathering all the knowledge, because when you cook, you have to understand about the history, where the recipes come from, about the geography, about the chemistry, of course, because lots of chemical reactions happen. And since I loved cooking and I loved science, I decided just to merge.
And this is why you are here, because, you know, the podcast is about And is the Future. So the A&D, and we are putting things which can seem in opposition, but people like you, heroes, right? They really put those two together. So tell me, you wake up one day and just say, I'm going to go from chemistry to cooking, and I'm going to do it as a job now?
Something like this, yes.
How did it start?
It started like I wanted to do science, and because science opened your understanding of everything around you. Yeah. And I also wanted to cook, and I said, so the best way to do science and to cook is to study the science of cooking. So I'm happy every day, because every day I'm cooking and I'm doing science. So that's perfect.
And you did it after your PhD on...
And I did it after my PhD, because the trouble is if you want to get a position at the CNRS, which is very selective, cooking is not considered as a serious subject. I mean, it's something you do at home. And so I entered the CNRS because I studied epigenetics, cancer research, connection with the food you eat. And this is something serious. But then I had to convince people at the CNRS that indeed cooking is also something very serious, because when you cook, you eat differently. And if you eat differently, it has impact on your health, on the environment, on many things.
Yeah. So this is delightful, because, you know, being French Moroccan, I grew up in Morocco. So obviously we had, you know, the delicacy of cuisine and the tagine and couscous. But French cuisine is also very well known.
Different.
I love the Japanese cuisine. I'm putting my apron today just for showing off, but you are the master today. So tell me about these, molecular gastronomy. Again, two things which seem in opposition, but it's about the molecular, which the chemist I am, we use atoms and molecules to produce our products, and gastronomy, which, it's your art. So how you combine both?
Gastronomy is both an art and a science. Indeed, gastronomy was defined the first time by Jean-Thelme Brillat-Savarin. So Brillat-Savarin is quite famous because we have the cheese, Brillat-Savarin, but it was a guy before. Yeah. I lived 2 centuries ago. He wrote the Physiologie du goût, a very, very famous book. Yeah. And this is in this book, published in 1825, that was defined for the first time the word gastronomy in French. Really? So gastronomy, Brillat-Savarin said gastronomy is the knowledge and understanding of all that relates to man as he eats. Yeah. So which means, as I said, if you really want to understand what you eat, you need to understand. And Brillat-Savarin said it is about chemistry, it is about natural history. Yeah. Doesn't talk about biology at that time, and physics. And so, and molecular gastronomy is just the understanding at the molecular level of all that relates to man as he eats. Wow. That's just a question of scale. Yeah. Like you have the biology, and with a microscope and atomic force microscope and electronic microscope, you have the molecular biology. Yeah. That's exactly what we are doing here.
But you bring more creativity and ingenuity like we do in our labs with polymers, right? You can sky's the limits.
Because the fact is, when you do the science, you understand things. Yeah. And when you understand things, it might provide some ideas to invent new recipes, to try new things. And that's how molecular cooking arises. Yeah. Because it started with the science, and then you have many chefs saying, oh, this is interesting what scientists are doing. Mm. And they start to do weird things like with liquid nitrogen, with alginate, with lot. And people start to call it molecular cuisine or molecular cooking, just to remind that this is about art, this is cuisine, that you have this scientific spirit, which is in the molecular world.
So it's a real science and space, because when the first time I was exposed to those molecular gastronomy, you have those fumes because you have liquid nitrogen. I knew that as a chemist, but it looks like showing off, but it's more than that.
It can be, it's part of the show. And that's usually what people know about molecular cooking, is this kind of spectacular things. But I would say, to my mind, molecular gastronomy is 99% only just understanding. Something very classical, like you make a mayonnaise, you make a chocolate mousse. This is molecular gastronomy. If you really want to understand and make it perfectly and know why you have to put the chocolate slowly with the egg white whipped, and why you should or not add some salt in the egg white, and everything is not spectacular at all, but this is real molecular gastronomy.
Wow. But tell me, at home now, going a bit more personal, when you grew up, right? Was your dad, your mom, your parents, your family cooking? Were you in the kitchen at all?
Mostly my mom, but as a kid I used to cook. Yes. Yeah? I already loved it.
So it started there, not only in the lab of CNRS.
No, it started before, mostly with cakes. Kids usually like sugar, so I cooked pastry. Yeah. But then when I grew up, I started to cook more seriously in many different things.
Do you have restaurants in mind or chefs, who are role models in molecular cooking?
Not specifically in molecular. Yes, you have many chefs, not in France, indeed, but Spain is very famous for it. So I have very, very good experiences in Mugaritz, in San Sebastian. Andoni Luis Adoris is a chef. And I used to teach at the Basque Culinary Center, which is part of around this restaurant, and it was really very amazing, and it was very clever, I would say.
And you were in Dubai, you said, is there?
Yes, also, and I used to travel. I'm lucky for that, and each time I go somewhere, I try to find a specific restaurant where there is something to say. So it can be a very traditional restaurant, or I would say the opposite, something very fancy that just exists at that place. And you want to be impressed. And sometimes you are impressed, sometimes you are disappointed, but that's the way.
Yeah. And in Paris, I'm curious, do you have students coming to your class and classroom just to study this? And how long does it take?
Basically, I have two kinds of students. I have students from medical schools and want to become doctors. And I teach them very serious things about the food and the health and cancer and things like that. And I have cooking students. indeed, students who wants to become cooking teachers. So there are teachers, but they are still studying to become cooking teachers. And that's most of my courses are in the kitchen because it's just to tell chefs how to become teachers. And for all this, most of them already knows perfectly how to cook, but they don't understand everything. And as teachers, they need to understand in order to better teach. So they make perfect stew, perfect souffle, but they don't know why. Just because they used to, and it's fine.
They have a recipe in mind and they follow the
And then with the students, it's not easy because if the student is failing, there is something they cannot explain. So I've just explained to them, oh no, if the souffle is working, it's because that, and that.
Yeah, I love it. I love it. So Christophe, let's start now cooking, right? And having some fun cooking.
Indeed, you find bicarbonate in many, many different recipes because it has two main roles. First, it helps to control the pH. So if you have something too acidic, a little bicarbonate in it. And that's why also it's good for your digestion because it can regulate the pH. And some people take bicarbonate when they have problem with stomach, things like this. So it's good for this. And we can see the reaction. Indeed, this is very, we always have to do experiment because we are not just theoreticists. We are
Let's do
practicists.
that. So a lemon.
So the very, very usual things you want to try is just to put some lemon in a glass, which is something about pH 2 or 3. So really acidic. And I got my spoon. And what happened, this is bicarbonate here. Just put it here. What happened if you put some bicarbonate
at that.
in the lemon, you trigger a chemical reaction. And in this, you just, it illustrates the two advantages of using bicarbonate is first, it kills the acidity, so it might be good for different reasons. But at the same time, you have this reaction that creates it's foaming
gas,
because there is lots of gas.
What is it?
This is carbon dioxide. And the good thing is if you use it in the kitchen, you can make foam in the kitchen. And that's indeed what people do when they put bicarbonate in cakes, is just to have a kind of like yeast, but not biological yeast, chemical yeast. And it does the same job. Because it just creates bubbles and you have your cakes just getting this huge volume. So we won't cook any cake here because I wanted to show you something very quick. Because we are short in time.
Next time we'll do the cake.
Yes, cake is for next time. So we will just make a caramel. But a special caramel. It has to be special. So to do the special caramel, I just use normal sugar. There is no magic in the sugar.
Because there is a normal sugar as well, or
no? You can use many sweeteners. But for caramel, it's not
this is traditional sugar.
Yes, this is saccharose or sucrose. Should call it. So about 150 grams. And sorry, I will just need
please
to
go
clean
ahead.
my spoon because I always
should not be on your way.
Spoon.
So 250
and about
in a pan
150, and I will put about. I also need to put some lemon, and I will put it directly here. It's about 10.
Half a lemon.
Yes, half a lemon, which will do something like 15 grams, I would say.
No reaction here, right?
No reaction here because it's just lemon and sugar. Maybe I will use a little more because I like acidity. And this is small lemon. Of course, in the kitchen, I'm supposed to use the balance for everything. But here, it's just to show the principle, the idea. And maybe just a little water to help the caramel, like this, just like this. Okay? And now, let's go with this.
Temperature.
So what happened? Yes, maximum. We want to be very quick. Because what happened here is a very classical chemical reaction, which is first hydrolysis of the sugar, breaks down into glucose and fructose. And after hydrolysis, you start to have caramelization reaction. And you create hundreds of different molecules that provides all the flavor, the color of the caramel and the taste, because you are lowering the sugar. But
the decomposition into smaller molecule happens at
It starts
at room temperature, or it's with heating?
It's with heating. I mean, hydrolysis at room temperature, yes. Yeah. But then when you eat, you accelerate hydrolysis. And then you start to have browning. And browning for the sugar, for this saccharose, it's about 150 or 160 degrees.
Yeah, okay.
And you have to be very careful because when it starts, you go very quickly from a nice brown caramel to a
ugly. You messed it. You messed it up.
And you missed it. So you have to be very careful.
So you have to watch what you are doing.
Yes.
That's what happened to me often. It's
usually
very
in the
black.
kitchen, you have to be careful. You have to watch.
That's fine.
So as long as there is still water, we are free to do what we want because it won't goes above 100 degrees, I would say. But once the water disappears, then you want to be very careful. And meanwhile, when this caramel is cooking, we will put it in liquid nitrogen. Because usually when the caramel is done, it's very hot. You have to pour it on a plate and wait for 1 hour in order to be able to break it and eat it. We don't have 1 hour now. So we will just put it in liquid nitrogen and in a few seconds we can...
Can we get liquid nitrogen at home? Because that looks very, highly sophisticated, right?
Here we have a special home, I would say. So we just came with this nitrogen that's here. I can put it here.
Watch yourself.
And anyway, at the same time, I have to check for my caramel. I have to put my glasses because we are supposed, when we manipulate liquid nitrogen,
it's chemistry, so safety first.
Caramel is almost done, so I just take it out.
I'll be a bit away. And I don't have glasses.
Oops, sorry. I just pour the liquid nitrogen here.
So that we know. It's very spectacular.
We have to be careful because it's minus 200 degrees. And this is the caramel. And I put bicarbonate in order to get a foamy caramel. Here's the foam.
Amazing.
And I put the foam.
Here we are.
In liquid nitrogen.
So frozen, right?
I froze my 160 degrees caramel into a minus 200 degrees liquid nitrogen. So this is really quick.
Very quick. Here when magic, embraces science.
And now that's done, so I don't need my glasses. And we just wait. And we
get this
out
of the way. So do you often use liquid nitrogen in your recipes or?
Well, not at home.
No,
But in the restaurant,
yes.
It depends on some.
And is it always to go quicker, right? In freezing
It's mainly you have to use it in front of the customers because it's for the show. If you just do this in the kitchen, this is not that useful. And usually you do sorbet or you do like La Tour d'Argent in Paris, very nice restaurant, very famous restaurant.
Absolutely.
They used to have a marvelous dessert. Philippe Labbé was the chef at that time. And they make, at the same time, a crêpe flambée and an ice cream with a liquid nitrogen.
So fire and
so very cold, very hot. And then they serve the customers and it was a marvelous dessert.
Look at that.
So this is,
look at that.
Caramel foam.
Caramel foam.
Lots of bubbles, lots of... And we will be able to eat. So I break it because we want small pieces. That's it. So only sugar, lemon, and bicarbonate. And the good thing with bicarbonate, you will feel it. It's a little salty because you have the sodium.
Yeah, indeed. How much bicar you put there? I didn't watch you good enough.
About 3 grams.
3 grams.
Like this. Because if you put too much, this is a huge foam, but then you feel it in the mouth.
So you say 250, right? Sugar. And then you say...
About 150 grams.
150, okay.
About 15, so 10% of lemon. To have the acidity and to have the reaction. A little amount of water. Don't know exactly how much. And let's say 3 grams of
bicar.
Yes.
Okay.
And I don't want to break this stuff, but maybe we can just show you this. Yes.
Wow, look at that.
You can really try like this.
Yeah, that's really nice. Yeah, thank you.
It's very cold.
Wonderful.
Salty and acidity.
And crispy.
And very crispy, yes.
That's great.
So you can
We're going to give some to the crew, by the way, for everybody, to the kids as well. Yeah, this is great.
To wait, but mm-hmm.
So this shows that at the end of the day, cooking is more than an art. There is science behind it. And what you say, which is fabulous, is more you understand the science behind it, more you can actually not only perfect your recipes, but actually do better things for the health.
You can do better things for the health, better things for the environment, better things as taste. Because indeed, again, Brillat-Savarin, when he talked about gastronomy, at the end, he said that it's also about cooking, which is the art of making things palatable.
Yeah.
Which means this is really the idea of it has to be good. That's the first goal. It has to be good. And if it is good, you want to eat it.
Yeah.
And then it's better if it is also good for your health and good for the environment. But if the taste is not good, there is no use to work on a dish.
Yeah.
So you really need to understand all the reaction and what happened in the brain and what happened with the sugar, with the proteins, and with everything.
So what's the best recipe you like to cook or to eat? It's
hard to say.
Hard to say.
So much.
Many things.
When I started to cook, what I liked in cooking is to start from raw ingredients, which means mainly vegetables, but also fish.
Yeah.
For animals, like mammals, it's a bit harder because you need someone to kill it and to prepare it. And I really like the idea to just catch real full ingredients and prepare it from the beginning. Usually I'm cooking vegetables and fish and I mean, sometimes a little piece of meat.
Yeah.
But and then you have all the creativity. You can think about when you are traveling, you have new ideas. When you read book about the history of cooking, you have new ideas.
Yeah.
When you meet chefs, it's weird things, and then you have new ideas, and then you provide the students. I try to give these new ideas to my students and make them think about new dish. And usually I told them, try something new and you will fail. That's fine.
That's fine.
Because
failing is good.
Failing is good, but you have to understand why.
You learn. Yeah.
Exactly.
Yeah. And
That's
you don't repeat your mistakes. So help me, I mean, you need good ingredients to, like anything else, I guess, good veggies, good fish farming can be also a bit, here and there. So I guess you look at the quality of your ingredients, and then I'm interested by the spices. Morocco, we're using a lot of spices and etc. So what's the role there in a good molecular gastronomy?
So of course, with good ingredients, I would say it's better, but it's also easier.
Yeah.
So usually what I say to the students and to the chef is having good ingredients and doing something good with them is a kind of responsibility. Mm-hmm. But also having bad ingredients and succeeding in doing something good is also a
challenge.
It's a challenge. And it's interesting because you have lots of kind of waste or things that people don't want to eat. Or let's say I got a kilo of tomato and I tried and it's not good tomato, but I have to use it.
Yeah.
And to use it, I have to think about the best way to make something good with bad tomatoes.
Sure.
And I will make a sauce and I will add some spices, and thanks to the glutamate you have in the tomato, you have your umami taste, and at the end the sauce will be perfect.
So, finish the experiments, Christophe.
Yes, that's finished. We'll just
show us,
can serve now.
Yeah. Wow.
That's it.
Can I try one?
And bon appetit.
Bon appetit. Let's try. Magic.
Just imagine on a cake, on a custard, and we have to put it on something.
Yeah, we'll take some with me. So tell us now, that the podcast is delivered to our audience. So what would be your best advice to young scientists and young chefs?
The same advice. I would say the first thing is always to keep open-minded, which means you have to be curious about everything.
Curiosity.
Curiosity is probably the most important quality for a chef and for a scientist. Yeah. And also, this sounds obvious, but you have to like what you are doing. Okay. You have to enjoy it.
Find your passion. Right?
Yes, because if you enjoy it, you will do it. I mean, you have a good chance to make good things and to be good at what you are doing if you really enjoy it.
Yeah.
Of course, when you are doing science or professional cooking, basically you work 15 hours per day minimum.
It's a tough job, long hours.
that's a disaster.
Yeah, don't do that.
So you have to have this passion, otherwise do something else.
Yeah. And you said earlier, failing is okay. You know, you learn from it, right? Learn and relearn.
And I would say in science, failing means you probably improve.
Yes.
Because if you don't fail, you don't learn anything. It's something obvious. Okay, I want to do this. I think it will make this, and it's exactly what's happening. So
and you eliminated one path because you failed. So you're gonna do something else.
So you have to fail.
So that's science.
You have to take risk. Otherwise, if you don't take risk in the kitchen, you do something that everyone is doing. And if you take some risk, you might do something different.
Yeah. So someone told me that music plays a big part of, in your life, and even you played piano at the beginning.
I used to play a lot. I started to, not professional, but I earn money by playing piano in a club. Yes. And
in Paris, right?
Yes, in Paris. Yeah. And in Tours, in the Loire Valley, that's a small city where I used to live.
Are you still playing?
And unfortunately, science, cooking, you can have everything.
You have your plate full already.
And if you want to try to be good at something, you cannot do everything. You have to choose.
But you listen to music.
I'm listening a lot of music and get some inspiration from music. And the fact it's all about emotion. Listening to music, playing music, cooking. You do it just because you want to create some emotion for you and for others.
And for the others.
So that's a bit the same, music and cooking. It's just
so next time, you didn't know this, but we will have a podcast with a pianist and a chemist. So it's fun as well. So that's perfect.
That's a good match.
Well, Christophe, thank you. I think you gave us a great gift today. A gift showing that end is not the future, is the present.
Yes.
And the real presence between science and art, between cooking and chemistry, including molecular gastronomy. And frankly, your generosity as a human being, as a scientist, as a professor, a teacher, a traveler, is a real inspiration for all of us and for me. I'm getting away, wanting to be in the kitchen.
I'm sure you are cooking.
No, not at all. My husband would tell you she's not really.
So you're lucky yourself.
But I'm a good eater.
Yeah. That's good.
I loved to cook when I was younger in Morocco. Yeah. That's today, having chefs like you, just watch and enjoy and taste. So thank you. Thank you for this beautiful gift. Thank you very much. Thank you so much for joining us today. For more information or to listen to other episodes, visit our website. And if you like these podcasts, don't forget to subscribe. Until next time, be safe.